A matrix M is given to you. Aij are the elements. Ij belongs to 1, 2, 3. That means, of course, it's a 3 cross 3 matrix. Okay, now they're looking for the elements. So you know, right? I stands for row and J stands for column. They're saying Aij is 1 if J plus 1 is divisible by I and 0 otherwise. So can you determine your matrix then? Okay, so your matrix is looking like this, let's say. Okay, now you are saying that M is equal to if J plus 1. What's J plus 1 here? 2. 2 is divisible by 1? Yes. J is 2, J plus 1, 3, divisible by 1, yes. So accordingly, you write your complete matrix. 4 by 1, yes. 2 by 2, yes. 3 by 2, no. 4 by 2, yes. Okay, again here, 2 by 3, no. 0, yes. 0. Okay, this is your matrix which you are going to get. Now check option A. It's asking you whether your M is invertible or not. Very simple. Get the determinant of M. Okay, what do you do? Okay, you just get the determinant. Okay, maybe I will open using the last row. Okay, negative 1 times the minor 1 minus 1. That's very simple determinant. It's 0. So of course it is not invertible. Okay, now B option says that there exists a non-zero matrix this such that M times this is this. Now you just write equation. How else you are going to do, right? M times a1 a2 a3. Okay, and you want it to be equal to negative times of the same. So let's write it as an equation now. You're getting a1 plus a2 plus a3 is minus a1. Second one gets you, just multiply, okay? You know how to multiply, is equal to minus a2. Third one is a2 is equal to a3. Just try reshuffling things, okay? You get 2a1 plus a2 plus a3 is 0. The second one gets you a1 plus a2 plus a3 is 0. And third one gets you what? A2 minus A3 is 0. Okay, no, this is minus A3. A2 plus A3 is equal to 0. Now it's an easy one, right? Can you solve that? Yeah, because A2 plus A3 is 0. If you plug in here, you get A1 is 0. The same thing you get even if you plug in on the top. That means if A1 is 0 and A2 plus A3 is 0, all the equations are satisfied. Correct? So can you make a solution here? You just want A1 to be 0, right? If you say that A2 is alpha, then A3 should be minus alpha. My alpha could be any non-zero real number, correct? Yes. So this is true, right? There exists a non-zero column matrix. Go to option C. Now C is telling you that this set, see, this set consists of all solutions of this equation. They are saying this set is not zero. That means again there exists a non-zero solution for this one. Okay, what do you do? Again, just do the same thing. Mx is equal to 0. Let's say my x is x1, x2, x3. Okay, so I get the same equation, right? Instead of a1, a2, a3, let me just write x1, x2, x3. So my equation would be x1 plus x2 plus x3, just that the right hand side would be 0. It's the same thing, okay? I'm just writing x1, x2, x3 and the right one hand side should be 0. X1 plus x3 should be 0 and x2 should be 0. That's what it means. Now can I get a non-zero solution from here? Let's solve it. Again, it's easy one, right? X2 is already 0. Okay, if you plug in x2 is 0, what do you get? X1 plus x3 is 0. That's the only thing you need to get satisfied, right? To satisfy all the three equations. Okay, so can you form a vector now, non-zero? Yes. X2 is 0. Now let's say x1 is beta. Then x3 should be what? Minus beta. Again, beta, I can take any non-zero real number again. Yeah. So that means, yes, this is true, right? The set is not just 0. There are many more elements here. Okay. Let's go to D. D is telling you that m minus 2i. How do you get m minus 2i? I is just a diagonal matrix, right, with ones in it. Okay, so when you do a minus 2i, minus 2 gets subtracted from its diagonal elements. So what is the matrix which you get? M minus 2i, tell me. Negative 1, 1, 1, 1, negative 2 and 1, and what is 0, 1 and negative 2. Now can you get determinant of this matrix? Okay, the determinant is what? M minus 2i. Okay, what is the determinant? Negative 1. This is 4 minus 1, then minus 1, and then you get minus 2, minus 0, and then plus 1, 1. Okay, so how much is that? You are getting minus 3, and then this is 2, 3. Okay, so you're getting it to be 0. Okay, so 0 means not invertible, right? The last one saying it is invertible, so this is not true. Okay, it is not invertible because the determinant is coming out to be 0. Not a difficult question, right? See you with another one.